What are stress concentrations? Fundamentals of material failure. Imagine bending a paperclip and noticing it snaps at a specific spot. That spot is often where stress is concentrated. Today, we're going to explore what stress concentrations really are and why they matter in material failure. Stress concentrations are tiny regions inside a material where stress levels are much higher than the overall applied stress. These spots happen because of changes in the shape or structure of the material. Think of a sharp corner or a hole in a metal part. These features cause stress to pile up locally. When a load is applied, these areas bear more stress than the rest of the material, making them prime spots for failure. To understand this better, we use something called the stress concentration factor. This number tells us how much higher the maximum stress is compared to the average or nominal stress. For example, if the stress concentration factor is 2, the highest stress in that area is twice the average stress. The bigger this number, the more likely the material will crack or break at that point. Geometric discontinuities are common causes of stress concentrations. These include sharp corners, notches, holes, or cracks. When a component has a sharp corner, the stress tends to focus there because the shape disrupts the even distribution of forces. Material defects like impurities or tiny cracks inside the material can also cause stress to gather in specific spots, leading to failure. Stress concentrations are especially dangerous because they can cause materials to yield or crack even when the overall stress is below the material's strength. When stress is too high locally, it can make the material deform permanently or fracture suddenly. Repeated loading or fatigue can make cracks grow from these high-stress areas, shortening the lifespan of the part. In practical design, engineers work hard to reduce stress concentrations. They might add rounded corners or smooth transitions instead of sharp edges. Using thicker or stronger materials can also help. For example, in designing engine parts or bridges, minimizing sharp notches and ensuring smooth curves help spread out the stress more evenly. Knowing about stress concentrations helps us understand why some products fail unexpectedly. By identifying these high-stress zones, engineers can improve designs to make products safer and last longer. This is why paying attention to the shape and structure of materials is so important in preventing mechanical breakdowns.